Here is a combined summary of the 4 pages. The current dominant approach for neural speech enhancement is based on supervised deep learning on simulated pairs of far-field noisy reverberant speech and clean speech. However, these models often exhibit limited generalizability to real recorded mixtures. To address this, the paper proposes training enhancement models directly on real recorded mixtures, leveraging closed-talk speech enhancement to compute high-quality pseudo-labels for real recorded far-field mixtures. The proposed system, ctPuLSE, involves training an enhancement model on simulated mixtures to enhance real recorded closed-talk mixtures, and then utilizing the estimated closed-talk speech as supervision for training far-field speech enhancement models directly on the paired real recorded far-field mixtures. The closed-talk speech enhancement task aims to enhance closed-talk mixtures and estimate closed-talk speech, which can enable many applications, including deriving high-quality pseudo-labels for real recorded far-field mixtures. The ctPuLSE algorithm utilizes a speech enhancement model, ctSE-net, trained on simulated mixtures for closed-talk speech enhancement. The ctSE-net model is then applied to enhance real recorded closed-talk mixtures, resulting in estimated closed-talk speech. This estimated speech serves as a pseudo-label for training a far-field speech enhancement model, ctPuLSE-net, on paired real recorded far-field mixtures. The physical model of the recorded closed-talk and far-field mixtures are formulated in the STFT domain, where the loss function for training ctPuLSE-net is defined as the sum of squared differences between the filtered DNN estimate and the pseudo-label over all time and frequency bins. To address time synchronization issues, a technique based on the GCCPHAT algorithm is utilized as a preprocessing operation prior to training. The ctPuLSE-net model is trained via single or multi-microphone complex spectral mapping, and a co-learning strategy is proposed to leverage both simulated and real data for training. The research paper introduces a novel speech enhancement system, ctPuLSE-net, designed for real recorded far-field mixtures. This system aims to achieve better enhancement compared to purely supervised learning approaches by incorporating a mixture constraint loss that encourages speech and noise estimates to sum up to the observed mixture. The loss functions are defined for both simulated and real data, with a weighting term to balance their importance. An algorithm is also presented for approximately aligning closed-talk and far-field mixtures to mitigate synchronization errors using the GCCPHAT algorithm. The system is trained on the QIIME-4 dataset, which includes both real recorded and simulated mixtures. SNR augmentation for simulated mixtures and co-learning with real mixtures are employed in the training setup. Performance evaluation is conducted through ArXiv evaluation, focusing on speech intelligibility and distortion. The proposed method is compared against purely supervised models trained on QIIME-4 simulated mixtures, as well as other existing models such as iNoiB, SpatialNet, USES, and USES2. Evaluation metrics include DNSMOS, WER, STOI, WBPESQ, SDR, and SISDR. The authors introduce the ctSE-net, which is trained on real mixtures and can robustly deal with microphone failures. System configurations for the evaluation are described, including the use of TF-grid-net as the DNN architecture and the hyperparameters for the model. Key results are presented in Table 3 and IV, showing that purely supervised learning-based TF-grid-net trained on simulated data obtains strong enhancement results and ArXiv performance on the simulated test data. However, the performance on the real test data is limited, with the ArXiv performance on the real test data being degraded compared to just using unprocessed mixtures for ArXiv decoding. This degradation is more severe in multi-channel cases, possibly due to the mismatch between simulated and real intermicrophone characteristics. This paper introduces a novel approach to far-field speech enhancement, known as ctPuLSE, which leverages estimated closed-talk speech as pseudo-labels for training supervised enhancement models directly on real far-field mixtures. The proposed method aims to improve generalizability to real data, a common challenge in speech enhancement. Evaluation results on the challenging QIIME-4 dataset demonstrate the effectiveness and potential of ctPuLSE, showing better generalizability to real data compared with other state-of-the-art systems. Ablation results of applying speaker reinforcement further improve the performance gap between SuperM2M and ctPuLSE. In addition, the paper provides a comprehensive review of recent advances in speech enhancement, dereverberation, and speaker separation, focusing on multi-channel and multi-speaker scenarios. It discusses various challenges, datasets, and evaluation metrics used in the field, including the Chime 6 Challenge, M2 Med Challenge, MISP 2023 Challenge, and AMI Meeting Corpus. The authors also delve into techniques such as complex spectral mapping, neural spectrospatial filtering, and convolutive prediction for speech enhancement, as well as the importance of leveraging spatial information and self-supervised learning representation for speaker separation. The paper highlights the need for end-to-end integration of speech recognition, speech enhancement, and self-supervised learning representation to achieve robust and high-quality speech processing, exemplified by the Wave LM model's state-of-the-art performance in various speech processing tasks.